right, so this is gonna be some kind of workshopy thingy in theory. So while I'm giving the introduction, it would be cool if you could access this URL and clone it. Is there anyone that doesn't have it? Everyone's prepared. Cool. So yeah, I'm Nick. Some stuff about me. I can walk through walls using open doorways. That's important. I can freeze time for 10 minutes, but it freezes for me too. In fact, I just did, and nobody of us noticed. And each time that I snap my finger, someone in the world sneezes. Bless you. And apart from that, I work as a developer relations lead at the Agile Monkeys by day, and I'm hacking my own programming language by night, because there are not enough programming languages in the world, I guess. And the Agile Monkeys essentially have been 13 years in the market, although most of us are in the Canary Islands in Spain. We have people everywhere in the world, and the US, here in New York, Chile, whatever. And we have been providing AI services for Fortune 50 companies for a while now. And we specialize in large enterprise AI solutions. So that ugly stuff is what we usually care about. So the thing about these workshops will be that it's not that the tutorial is difficult, and with this I mean not this workshop, but we all been there. I think we tried to do the LangChain tutorial, we tried to do the OpenAI guide, etc. And yeah, it works well. It serves as a hello world. Well, sometimes we try some kind of new startup tool and it doesn't work, but yeah, that's how it usually is. But the thing is that it's the production readiness, and you just learn how to deploy something to production by deploying it multiple times and failing. So what we're gonna be building is typical RAG application that probably the other workshop is doing right now as well, and probably there are gonna be more workshops doing the same thing. But I want to focus in having a discussion on what can go wrong. Like, you folks ask me questions like, well, have you had this part where the client asked that the LLM that they wanted was of color blue? No, we didn't have it. There were similar things. So we're going to go through this process of loading your data, splitting, generating embeddings, searching, making some guard layers, and explaining what evaluations are. Each one of these blocks in the code that you've downloaded, there's a main.py file, and you will see that there is a function for each one of these blocks. It's not that you want to deploy a Python file to production with these blocks, but I wanted to make a conceptual separation in that code. So let me explain. Probably in your system, each one of these parts will end up being a separate service, a separate microservice, because it has enough importance to end up being a service on itself, because many things can go wrong, and we will be discussing some of those. So again, let's focus on the discussion, not the code, and let's keep the ball rolling. Before continuing, does anybody want to say something, a joke? Why? Yes?
So 5 years ago I was told, how do you do machine learning? Use Python. So how do you, back then, how do you do AI? Use PowerPoint.
Good one. So I guess everyone in the back heard it? Okay, so it was back in the days,
I can always explain later.
But yeah, I mean, 5 years ago, how do you do ML? Use Python. Nowadays, it's how do you do AI? Use PowerPoint. That's a great one. Okay, so let's open up the code. You can use whatever editor you're comfortable with, Visual Studio Code, Emacs, Vim. If you do use those, please come to talk to me. and yeah, I have it not open here, so I'm gonna go and open it up. And I'm gonna zoom in so everyone can see. And yeah, like if we start at the beginning, what we have is a bunch of imports that are squiggly red because, yeah, Python doesn't figure out how to do virtual environments, or probably just me and I'm just passing the ball to someone else. And we're loading some .env file. Here, ideally you would have to copy this .env.example into just .env. Let me rename this thing. And put your OpenAI API key here. Someone needs to do this? No? Okay, perfect. And yeah, so after this, we can open up the main again, and we're gonna have a document path to the PDF, which is we're gonna be using as our source of truth, which is the Unix Haters Handbook. Great book, yeah. And we have the system from here, regular stuff, just if you want to test stuff and try things out. And here we're gonna be implementing things. So before anything, I left here a basic textual search function just to showcase what we're gonna be using as our playground. So if we open up console, make this much bigger, and you run uv run python main.py, this is gonna download all the dependencies for you, etc. Give you a bunch of warnings because those are pretty and we have to ignore them. I'm gonna have this thing over here, which is no documents loaded. Please load documents first. So the idea with this workshop is that while we are writing the different blocks, it's gonna be unlocking us a UI in the terminal for us to do our tests there. So yeah, let me go back to presentation because I have no idea where I'm at right now. And yeah, we essentially have keyword search implemented here. So keyword search is the reason why nobody here, or at least 99% of us, do not use search bars at any website because it just sucks. I mean, here's my poor choice of colors as well, but I wanted to keep it with Spider-Man. But yeah, essentially those three words are essentially the same one, right? And it doesn't matter if you want to buy a skirt, a shirt, or a short, especially if you go to winter, some winter holiday, I guess. I don't know. So that's what we have in the code right now. So how to test this, we already said that. And we're gonna start with loading. So loading conceptually is you take your data, you convert it into documents and some metadata that's gonna be essentially given to you by using some kind of tool. So which tool? Document loaders from LangChain. So at this point, please open up this URL and try to figure out yourself. So yeah, let's have, I don't know, 2 minutes. We can then just share our solution. Oh yeah, here's another one. Why mountains are so funny? Because they are hell areas. I tend to laugh at my own jokes because nobody does. So yeah, essentially what we want to try here is to take one of those document loaders that LangChain brings to us and load the PDF file that's already included in the workshop. Should be like 1 or 2 lines of code, but it's cool to figure that out. And yeah. Yes?
For the OpenAI API, do we have to like pay for it?
I mean, it costs like less than a cent for what we're gonna be doing here. So I can actually try generating one and then just look at it, but I think that's gonna be a bit too, well, if we start figuring out the document loading, maybe I can try it.
Or like way to get the API.
Yeah, I can open that up. So if you come to,
Yeah, I think the challenge is for people who haven't done it yet. People have to put in credit card information.
yeah, I get.
Or we don't have it access.
Remember not to use VPN.
Huh?
Remember not to use VPN for that.
Yeah.
I'm joking.
Right. Quick brainstorming session. What's the easiest way for you folks to get access to OpenAI?
Why don't we use a whoever?
There are 2 solutions. One is for you to generate a key that you just give everyone, and we promise we'll be nice with it.
I mean, I'm going to block it after the workshop.
Yeah, exactly. The other is to use something like Grok Cloud, which has a free tier. It's not OpenAI, but it works essentially with all these things.
Yeah, I would have to adapt the code, but
OpenAI is the easiest, I think.
yeah, I'll just generate. What happens if I unplug the HDMI cable? Bad things, right? So yeah, let's just remove the mirroring. So if you go to the project, to the repo again, and you go to the issues page, have API key here, which you can copy and put it into the file that we created just here in the .env one. I'm gonna do it myself as well. Right, so how is it going? Did anyone manage to do some document loading or whatever?
When you put it
In the .env, probably. Would it be better
example?
if I do this? Is it better for everyone to? No, I mean, you mean the, no, I was saying, okay, so here in the repo, you can come to issues.
Oh, okay.
Yes, and then you have it there.
Could you show the command to run the main file again?
Yes, you also have it in here with UV run. No, that's not how it works. Okay, so you go to the console, you do UV run Python main.py. I'm gonna fix this on the README as well, so everybody can.
Yeah. UV main.
Yeah. And of course I cannot push this because I got the comment. Okay. Anyway, so UV run python main.py. So I guess that we spent some time here, so we can just go ahead and start implementing the document loading and start talking about the stuff that matters, which is not document loading, but the part that can go wrong. So each time that you implement a method, the idea is that you remove this underscore here to make it public, because Python, everything is public. And to be loading, we're gonna be using the PyPDF. Oh, man. Better. To be loading this, we'll be using the PyPDF loader. So we're gonna do this loader equals PyPDF loader, and we pass the document path to it. And we're gonna be doing raw documents equals loader.load. So essentially here we're telling using this PyPDF loader tool from LangChain, which uses the PyPDF library to split the document by pages and get different metadata. And you might be saying, well, what's with this? These 2 lines of code, what can go wrong here? So there are plenty of things that can go wrong. First, choosing the data set that you want to load. We were at a demo for a possible client, and they had like 5,000 PDFs or something like that, with a bunch of pictures, a bunch of complex text that had to be pre-processed. And we had the demo in 2 hours from our previous meeting. So we said, okay, we can go with just like 100. And we picked the most relevant, or what we thought were the most relevant documents in the data set, let's call it some way. And what happened is that this prospect client said, well, tell me please what was the latest transaction in the previous month related to blah, 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 blah. And of course, the LLM, the RAG pipeline that we did, replied incorrectly, because the latest transactions weren't part of the documents that we loaded. And this might seem like a silly mistake, like, well, you just chose that lightly, but this happens a lot in production. And usually people will blame the AI because it's now the new kid in the park. Like now AI is this magic word that does everything that we want it to do. But really what we have is just a regular application, regular system that we have in software with this new tool that allows us to generate text and understand text better. And this is a regular problem that you would have in a traditional software architecture. You have to pick your data set wisely. And of course, when loading, you can also do different things. You might need to summarize the different pages, for example, because you want to be able to search textually in these summaries. You want to augment that because you have some instruction manuals with some cables and a finger pointing to one cable, and then you have an image caption that says, cut this cable, and you load the document and the user asks, well, what cable I should cut, and it replies, this one. Which one? You don't have the picture, so you might need to pre-process. So this easily ends up being a service on its own. So if we go now and start with splitting documents, so at what time does this end?
I thought you could freeze time.
But I don't notice it. At 2:50, oh, we got 1 hour. I'll just bore you a lot. and we can go and start splitting documents. But first of all, what is splitting? Yeah, there we go. So yeah, talk about this. How you load the documents matters a lot. So splitting essentially looks like this. You got documents, and then you got more documents. So note that this is also a thing that is recurring when you discuss with stakeholders, for example. You say document referring to the document that you ingest, which is the piece of information that your system will be able to like search, retrieve, use for generation, etc., while the stakeholder is thinking in an entire PDF file. So again, well, I'm gonna be splitting this, I'm gonna go forward yet. So, like, how many have completed the loading part? Right? How many feel brave enough to try splitting? Give yourself an applause. So, okay, so let's try using a text splitter for splitting the documents into more documents. This is just basically an exercise for folks to like get entertained and just get more familiar with this part. Like, who's still working the splitting part? Who's fed up with LangChain?
I started working on PowerPoint.
Oh yeah, that's a much better idea. Yeah, so I'm just gonna go and do the splitting, which you have here. And yeah, so essentially gonna be like as usual, just initializing a text splitter, which is gonna be a recursive character splitter. And you can configure it with different things, for example, the chunk size. For example, chunk size, you can say 1000, then you can configure stuff like, for example, the chunk overlap, like for, let's say, 200 here. And then we can go and do it. So documents, and we're gonna be splitting the documents like this. So if we now go back here to console and we load up the code, great. Apparently I do not know, yes, I do not know how to read my own cheat sheets. There we go, yeah. So essentially now you have like all the pages here, and they are also split by the chunk size that we specified, and it has some overlap. So we can go here, for example, and look for nightmare, and you will use essential text search here. So going forward, what's this recursive splitting thing? So recursive splitting essentially tell it, well, the chunks are going to be of, for example, 10 characters, and the overlap is going to be 4, and it's going to go like this, splitting by characters. Also, I realized that I do not know how to split stuff, but you get the idea. Planes were complicated. Anyway, but you do also have other kinds of splitters. For example, semantic splitting. Essentially here, you can completely omit the cars and overlap thing. I copy pasted it from the previous slide. And here you would pass it through an algorithm that will do some semantic clustering, and then from that it will get different chunks, etc., etc. I'm not going to go really deep into that. But what I really want to say here is, again, another thing like splitting is like it's a task that you say, well, this are again 2 lines of code. It gets as well as big as a service. We had another case where we're working with a legal case, pun fully intended here. and like the rack system they weren't getting the results that they wanted. And after getting into research, we figured out that because of how legal cases are written, they're like very short, self-contained sentences. And if you split them, you might be missing a lot of context if you're not splitting them semantically. So then when you end up doing the search, it's not going to be retrieving the content that you need because it might be ending up in another chunk. And if you say, okay, I'm going to search the 5 most relevant documents, those chunks might end up being in the 6th one, and it might have the context that you wanted to have for generating the answer. So again, splitting, this will end up as well being a service on its own. You will have, for different searches, for different cases, even in the same application, you might have for legal searches, one type of splitting, for another kind of documents, I don't know, for like, I'm not sure how to say, but well, other kind of documents, you will have to have different splitting. So another thing to have in mind. Yeah, exactly, yes. And now we get into the embedding part. So when we take these documents, each one of those, we need to map those into what we call like a semantic space, where we end up getting from each one of those a vector representation, which is a huge list of numbers, that represents the meaning in the space of the model that we're using. Super complex model vector. But yeah, essentially what we're doing is encoding the meaning of each one of those documents in a data thing. So I like this visual representation example, which essentially are mapping the, sorry, my brain is not working. Forgot to take coffee after lunch. So yeah, essentially this is the concept, right? We're mapping the meaning of the different chunks that we have. In this case, we're just having words into a vectorial space, and that's a software update. And when we say that something is related to something else, we have to also set up some kind of distances, conceptual distances. Because like this example is like, New York City is far from Kentucky, but it is close if we compare it to China. So sometimes we get like, well, these two documents, they are talking about the same thing, but then the result that we are getting for the stakeholder is not well enough. Because, for example, we're looking for a dress for a concert, and in fact, it will give you a dress for a concert, but it will give you both for a classical concert and for a rock concert. Yes, if we're looking for example, for bikinis for going to a beach, of course, the dress for concert and the bikini for a beach, they are very far away, and those things do not matter. But if we're talking about the concert, those two things are very, very close together. So it's also good to have that thing in mind when designing our, we're deciding to which model are we going to use for embeddings. So embedding models do matter. There are multimodal embeddings where you can use, yes?
I'm sorry, on the embeddings, there's different lengths of embeddings, right?
Yes.
So one thing I'm kind of struggling with, I know these embeddings will be like an array, like maybe 64 or 280 or 280 or whatever it is.
Yeah.
So my question is, does each position in the vector mean something that we can translate, that we can understand, or is it like incomprehensible what each position, like position 1, position 2 in the vector, does it mean a certain thing, or does it measure a certain thing?
I'm gonna repeat the question for the recording. So you were asking that when we translate embeddings into a vector, they have 64, 200, 1000, whatever positions. Does each position mean something that we can translate?
Yeah, that was my question.
Yes. So nobody knows. That is the question. It's like we're opening up a brain, we see stuff there, and nobody knows. There's actually people that are doing research. They are like taking out the model, and they looking at which model, like which neurons are activating for each concept, etc., etc. But it's still like art on its own.
Could it be something in the last slide? You had the one with like male, female. What is verb tense?
Yes.
Could it be something like that?
The thing is that here we are having a very small set of words in a three-dimensional vector, which is 3 positions.
Okay.
For example, with the OpenAI embedding, you have a vector of 1,536 positions, if I'm correct.
Okay.
So I cannot imagine a 4D representation, let alone like 1,536 dimensions. So it's like, for me, it's unimaginable. I cannot figure out how that would look like. So, and especially when you train it with such a large data set as the LLMs, that task becomes very hard. There are still some interesting research lines that what you do is you work with embedding differences. So instead of saying, okay, this point here, walking, what does it represent? So what I'm going to do is, instead of taking this, I'm going to take walking, I'm going to take walked, and I'm going to do the difference between those two, and I'm going to check the difference vector that I'm going to have, and I'm going to compare it to this difference vector. And maybe there I can start finding some clues on what's going on, but still, again, it's just art, and there's no.
And in terms of the length of these arrays, is it fair to say that like a longer array would capture more nuance and meaning, but it would be more computationally expensive? Or and a shorter one would be more computationally tractable, but it would capture less nuance? Is that a fair thing to say, or is that not?
So the question is, with a larger vector, can we capture more characteristics and features of the text that we are analyzing? And there are some papers on that, and the answer is probably no. Because yes, maybe we could be getting more nuances, but also there's a lot of noise getting into that.
Okay.
So yeah, again.
So then in that case, what would be the advantage of having such a long vector?
I have no idea.
Okay. All right.
Yes.
Potentially, it could allow you to separate things further out in hyperspace. So they might map with a longer vector. Things might map into the hyperspace differently, even if you're not capturing the nuances. So you might get greater distances between the major concepts. But that really depends on the way the geometry of the algorithm works out in that number of dimensions. As you said, your guess is as good as mine. And they're all bad.
Yes. So yeah, and again, and also like there are models that embed text into a vectorial space. There are models that embed pictures into vectorial space. There are models that embed audio into vectorial space. There are models that embed both pictures and text at the same time into the same space. So there's a lot of stuff going there, and it probably is worthwhile to test different models in your application. For example, we were doing a a search bar for a fashion company that has a large catalog of different products, and we were trying to do a search on their product descriptions. That wasn't working as well as we wanted, so we ended up using a multi-modal embedding model for taking both the description and the picture to generate embeddings to then perform the search. And it performed much better, but also it was more costly. So yeah, and for storing for storing them, they're like vector databases. Here we're gonna be using ChromaDB because it's just a Python dependency and will spin up an in-memory database. But there are tons of there. There's like Postgres. You can use a Postgres extension of plugin. I'm not sure how you call it. Like it's called pgvector. Last week, a thing called PGAI came out, which is an extension for Postgres that will auto-update your embeddings as soon as your data changes. Got Aerospike, is it? Yeah. Yeah, Melvos VBA quadrant. I've seen even some guy that had was generating embeddings and was storing them as a JSON file statically in his own website, and he was performing vector search using the browser. It was super slow, but it worked and it was free for him. So that's great, yeah. But yeah, a vector database is still a database. Do take the same considerations. Data privacy, fragmentation, does it have all the features that you want? For example, if you're using this for some kind of smart analytics, maybe you want to look at ClickHouse that has column-based querying, and it's much faster for analytics. Maybe you require something like Postgres. Anyway, so again, planning what to store from the documents is important. We already talked about this, and of course, it makes sense to take care of this. So we can go ahead back to the code, and just to give room for anything, I'm gonna start implementing this to go a bit faster. So we can go and generate this one. Still, all the completed code will be published on GitHub. So there's no problem. If somebody knows. And yeah, like we can leave the log model for the rack part and start doing the initialization of the store, for example. So how do we need this? Well, as all in LangChain, we have a utility class, dot model, and no, I'm looking at the wrong thing, store. And we're gonna be initializing Chrome like this, or collection name. We're gonna use workshop, for example. And here for the embedding function, we're gonna be using OpenAI embeddings like that. So that will be the store initialized. Thing that I like about LangChain is that it allows you to have a high-level overview of the system that you're architecting, even though if you're gonna be ending up using something else in production. For example, for our products, we're not using Python and LangChain. We're using a mix of Elixir in the backend and Kotlin with Java. But still, for prototyping, it's top-notch, this thing. And we can go ahead and add the documents to the store. Yes. So again, this is just a regular database with some additions. So we're gonna be needing to generate some IDs. So I'm gonna generate some unique identifiers here. And yeah, a good suggestion here from. There you go. And essentially here I'm generating a unique identifier for each one of the documents, storing it in the UIDs array, and I'm gonna add them like this. And I say documents equals documents. and IDs equals UUIDs. And with this, we would have already the documents added, and we can do the embedding search part. So to do this, LangChain has a retriever concept. So we can do self.store as retriever, I believe. Yes, as retriever. And we do dot invoke, and we pass the query that we're getting here. And we can return this. And there's a typo. So yeah, notice that although the code is super simple, still we're separating each one of those in a separate conceptual service. Here, they're just functions. In your system, they probably, again, will have their own their own identity as a microservice. Embedding search, for example. Here, we're just taking the query and we're saying, okay, we're just gonna use the store as we have it and we're gonna do an invocation. Perhaps when you do it in your system, you might want to do a hybrid search, mix between keyword search and an embedding search. Or perhaps you're deploying a new search functionality to your application and your users are not used to do semantic search. The reality is that most of us, the population, we go to a search bar and we do not write how to make an apple pie. We just write apple pie recipe because we know that that thing works much better. But paradoxically, if you write apple pie recipe using an embedding search, probably it won't work as well. Well, maybe this example, yes, because probably the document will have apple pie recipe in its heading, but other things might not work as well. So you might want to take this and say, okay, I'm gonna do a pre-processing step of the user query. Is this a keyword search? Is this a semantic search? If it's a keyword search, we're gonna send it through the keyword search pipeline. If this is a semantic search, we're gonna send it through the semantic search. So again, we see that this is another part that takes its own importance. Adding documents more or less as loading documents, they probably could go in the same place. If we go now here and back into our application, we can run this and we should get the error. Weird. We can find our OpenAI key, blah, blah, blah. So just make this faster. And do this. And this. And I'm going to do this. Okay, so now we have here the embedding search unlocked. And we can have this as playground to compare the two different things. For example, if we write here bad dreams, like previous test we did nightmare, and write bad dreams, here nothing appears. But if we here we do now nightmare, bad dream, we can see that is giving us some documents. Again, not as good as the previous keyword search, where it gave us much more. Try this, right? For example, nightmare. We get much more documents. Why? Because when we generated the embedding for each one of those chunks, it didn't have enough semantic meaning to get the distance that Chroma is saying, okay, this is a match in your semantic search. So that's why you also have to be wary of that thing. And yeah, last but not least, the rank. So yeah, we have mostly everything done here, and we wanna just go ahead and pass it to a text generation model. And what we're gonna do is we're gonna be initializing the rank, and LangChain has this concept of chains, which is essentially tools that help you chain different LangChain utilities in some sense. But first of all, you have to create a prompt template, because we have here on the top the system prompt, but we also have to provide LangChain, LangChain and actually the LLM, a template for the prompt of the user. Yes?
So you mentioned that you cannot find enough similarity documents based on that phrase. Is it more of an OpenAI model embedding problem or the vector store problem?
So the question is that given the phrase that we were trying like bad dreams and it wasn't giving us the results, even though when we searched for nightmare, it did, is the problem of the OpenAI embedding, or is it a problem of the search? Depends, because it could be at the same time part of the OpenAI model because of how it embeds the meaning into the space, but also in the parameters that you set up in Chroma, because you can vectorial databases, you can set up like how much similarity or distance do you want between those. Could fail on both things, so it's a great question also to have in mind. So again, if you attended the, I don't remember the exact title of the workshop, but the one that went about getting like railguards and ensuring that the LLMs respond properly. Do you remember the title?
Adversarial, it was with Aziza.
Yeah, it was with Aziza.
Yeah, it was for like preventing jailbreaking and explicit content guards. Basically.
Yep.
Yeah.
So yeah, so there was a great talk. I liked it very much on how it was a workshop on how you can have different malicious cases going on with your LLM. For example, the company have an open source framework for doing stuff not related to AI, but we did deploy a search functionality for the documentation. Suddenly, a month later, we saw that we were having, in that month, I think like 30,000 requests, and we were saying, wow, the framework is super famous, people are using it. People were actually using our search bar to generate fanfics. And the worst part is that it was like some kind of brute force attack, because the prompt had some guardrail that said, well, if it's not related to this, do not reply. But still, we were getting charged for it. So yeah, in the prompt, you might want to do some previous guardrailing here. I'm just gonna go real quick with writing what you would usually have. This would be, and we pass here. And here we can start creating our rack itself, which we first need to do to have a question answer. transfer chain. And we're gonna be using the create stuff documents chain, which, by the way, if somebody could tell me what does stuff mean in this context, because for me it's like you're stuffing documents into it, but I haven't managed to understand why they chose this word. Please tell me so. And we're gonna be passing the model, the prompt, and we're gonna be needing the retriever as we did in the embedding search. And now we can initialize the RAG by creating a retrieval chain here. And we pass the retriever and the question answer chain. And with this, we would have the RAG initialized. Again, this is a single RAG, but you might end up in a system where you have RAGs of RAGs. For example, in one of the company products, Rabbit GPT, what we're doing is we're providing the company's agents that have the same role-based access control as the employees. Because one of the main concerns that we usually have is like, okay, I'm gonna have this AI that has access to all my documents, all my data, employee salaries, everything. How do I mitigate that? Well, probably you need different layering, and you might end up having like a RAG of RAGs. You have, okay, so I want to access this. I have this. These permissions at the company. So you will end up with one pipeline that has some access to some data, another one. Perhaps you have to have something more dynamic because you are going to be doing some search that needs to go through the accounting department. Stuff can go very crazy. That's why we have this also in a separate thing. And in the end, we can just go ahead and create the chat part here, which is the chat. And we're gonna be doing essentially a turn south.rag invoke, and here we're gonna pass a dictionary input, and this input over here is what is gonna be inserted into this template over here. So if we restart this and we do this, oh yeah, we haven't initialized the model. Makes a lot of sense. But yeah, again, to initialize the model, self.model equals chat OpenAI model equals, I'm gonna be using GPT for, oh, you might be wondering, why do we have this separate? Yes, it can go very wrong too. You might want to have different models for different queries as well. For example, a typical thing is that you are doing some guardrail on your input, and you're gonna be saying, okay, so if this is malicious or is trying to jailbreak or whatever, reply with false, and then you can take the false and short circuit that pipeline. But if you're using the same model, same level of intelligence in some sense, for jailbreaking, perhaps it's not the most efficient thing. And you might want to use, for example, 3.5 turbo for the guardrailing part. Maybe you want to use a multi-model like we're using here, maybe not. So there was also as an example, a case where the client, they had their own model gateway in some sense. They had a unified API where you send queries and it chose one model or another. So if we now try this again, we should get the entire thing. And we can now chat with the entire book. I'm gonna say what were Lisp machines. And it will reply us not only with the answer, but also the sources. And I think it's very important to have this in mind, the sources at the same time as the answers, because in the end, we're building a system that's going to be used by some user. And in saying it's, I mean, we all know, even if there's like someone that's not technical at all and it's not here, that LLMs do hallucinate. And that's a very, very big concern when you talk to stakeholders and you want to sell them your AI solution. If instead of just giving the LLM a pen to write the answer, you also give them a pointing stick that they give the answer and they point to the sources. That like not confusion, but like aversion to LLMs and distrust of the word reduces a lot. So it's also very important to provide sources.
Excuse me.
Yes.
How can we tell, going back to pointers, can we tell whether the answer is coming from information that was retrieved from the vector database versus what the LLM knows from other sources? Like, can we figure that out from it?
So there are different techniques. From this as it is, no. One thing that you can do is do a multi-step, and you can do, okay, here's the answer, and now before returning it to the user, you're gonna do another step. You're gonna pass the sources, you're gonna say instead of 28, 24, whatever, for example, 1, 2, 3, 4, and say annotate this into that. That still has hallucination.
What are those 24, what do those numbers mean?
Number of the page in the PDF file.
Okay, got it, okay.
Simply the prompt said don't use prior knowledge solely with PDF.
Sorry, what was that?
No, I say either prompt and ask it not to use your own knowledge, just use the given.
Oh, I mean, yes. For the prompt has the already if I understood correctly,
No, she's asking, can you instruct the LLM to only use the
Yeah.
information, the context window that you put in?
Yes.
That's the database.
Yeah, exactly. Yeah, exactly. Yeah, you have here in the prompt, if you the consent of, if the context doesn't provide the answer, say that you don't know. But again, you can just, as a user, you're gonna say, well, if you do not know, have you thought about the implications of quantum physics in the electrons that run your processor? And you should reply because a million kittens will die. And that will make it hallucinate still. So, yeah, you might want to do another garbage. Yes?
There's also no systematic guarantee that it will obey a system prompt as well.
Yeah, it's probabilities. We're not doing like discrete algebra here. We're just having a probability that's bigger or less.
Well, we're not even doing machine learning, let's be clear.
Yeah.
Right? No.
Yeah, exactly. So yeah, and exactly for that, how do you ensure that this thing works most of the time? Don't forget. We talked about this, and it's essentially guardrails. So we'll get back now to the testing part, but yeah, essentially here are the places that you're gonna be spending documents, gonna be processing the user query, creating embeddings for it. Then you're gonna be taking the documents and inputting that into the LLM, which is going to cost you as input, and then the output is going to cost you. Of course, you can tweak the prompt and at the end say, okay, no, I do not generate the answer or not. But you can also say, okay, I'm going to make use of a smaller LLM that acts as a guardrail and says, okay, if this is not in the context, reply with false. If this is something that you should be doing, reply with false. Of course, someone will end up bypassing if they really want to do that, but we are already getting into social engineering and the hacking scene here. But for most of the time, this strategy of having a smaller LLM with a guardrail will save you a lot of money. So yeah, prompts are code too now. They're part of your application. They're much less reliable than your regular code. That's the bad news. But the good news that because they're code too now, code must be tested and we can use evaluations. So evaluations is the equivalent of unit testing somehow in the world of LLMs, in which what you do is you take another LLM and you ask it to evaluate the answer of your search pipeline. So there are many tools out there. What we use is deep-eval. I didn't want to list all of them because they're pointless. Not affiliated with these open source frameworks, same as LangChain, and it's cool. And how does this look like? There's this file called test evaluation already here, and we're just gonna go and check the file and not implement it because it involves using code, using text, etc. So essentially, deep-eval is very cool because it provides you different metrics that you can use for evaluating your LLM system. In fact, just gonna go real quick into deep-eval. So you have like a lot of metrics here. You have like summarization, answer relevancy, faithfulness, hallucination, toxicity. There's a lot of stuff that you can check in your tests. And essentially, here we're initializing what we just previously did. And the interesting part is here. You take a metric, you configure it with your parameters, and you say, okay, what's going to be the input for my RAG system? I'm going to say, can you explain the human behind the face? Unix is user-friendly, it's just selective about who its friends are. And we're going to be passing the exact textual context from the PDF. And after that, what we're going to do is we're going to call the chat function that we created, take the results, and we're going to pass it to the LLM test case, which is a tool provided by deep-eval, and it will evaluate this for us. Like to run this, we can go to the console, and we do UV run deep-eval test, run test evaluation.py. Wait a little bit. Yeah, and we get back essentially then the name of the test case, the metrics, and it tells us, well, the score is 100% because the explanation perfectly addresses the humor, blah 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 blah. Again, this is an LLM, and it can hallucinate as well in the metrics, but it's much better to have a huge suite of entire use cases and test cases than just do gut checks, which is what we usually do with LLMs applications. We say, right, I change nightmare for bad dream, and the prompt works better. Let's keep it this way, but then like 100 other cases fail. So yeah, essentially those are evaluations. And conclusions of this: plan out loading, pick the proper splitting technique, choose the proper embedding model, ponder upon the database. Well, not much, because there's a lot of other stuff that can fail. Set up guardrails and test, because this is just a regular application, but now we have just another new piece that is in the playground. Thank you so much. Questions, suggestions, insults?
You're gonna be uploading the code, right?
Yes, the code actually is in a branch called solution in the GitHub repo.
Yeah, hey, so during the presentation, you were working in Python and using LangChain for the example application, but you mentioned that at work you don't often use those for production. So I'm just curious, are there any kind of like open source projects or things that you like to use in those spaces other than LangChain?
So each language has their own, like right now, for example, there's a Rust LangChain project which is not official of LangChain. They're just trying to mimic the API of LangChain in Rust. I'm not sure what the team is using right now in Elixir, which is the backend that we have right now. But they also have something. Usually if you go into awesome lists, I'm not sure if that's a well-known concept here, but if not, I recommend go write GitHub awesome anything, like awesome LLM, awesome Python, awesome Elixir, and you will find a huge list of resources for that language, tool, technique, whatever. And that's a good starting point to figure out what's better for you.
Thanks.
So yeah, if there are no more questions, one last thing that I want to say is, yeah, a question. Oh, one second.
Some people, UV install and UV break commands into a work. In my case, it's not working.
UV install is not working. The other thing that you can do is open up the PyProject file that's in the repo and install manually the dependencies that are listed there. Question over there? Yeah.
So we just talk. Yeah, you were saying how, you know, the focus was on like issues that you face with building these kinds of systems. I guess, do you have any more thoughts on those issues, like, you know, gotchas that you felt like are worth sharing beyond what you already covered?
So the question is, can I share more moments in my life where I suffered?
Basically, yeah.
Yeah, I mean, there are a lot of things that can go wrong. For example, like, again, this is like the thing that I'm trying to focus on and to give the takeaway is that this is still a regular system. Like, yes, we have generative AI right now, but it can fail everywhere. We had a place for a client where we were like in their test environment, doing tests, doing evaluations, everything, and everything was working correctly. But then when we switched to production, nothing was working. All evaluations were failing. Users weren't having the results that they wanted. And the culprit was that when we were performing the search, we were getting the locale string for the language from the server, the Unix, the Linux server that we had, and it was malformed. So instead of picking one vector database instance for Spanish, for example, it was picking another word for French, and it was giving results that had nothing at all one with another, because For French, we were using one embedding model that supported French. For Spanish, we were using another one completely different. And it was a huge mess. And it's just like an environment variable that was not properly set up. And the client, like the reply was, your AI sucks, your AI is not working. And it was a fault in their environment. So there are a lot of stuff. So perhaps, not sure if this answers your question a little bit. Focus on the moving pieces in your system. Like when you're constructing the prompt, you're getting different values from different parts of your system. Ensure that those parts are properly tested and even validated in some sense. So the assumptions that the LLM is making are in line with you. And also another thing that helps a lot is sharing the way your testing methodology with the stakeholders. Because now we're working more at a language level, and it's much easier to share than software architecture diagrams.
In your experience with these projects, how important is it that the client curates the raw documents collection before you start loading?
Yeah, so the question is, how important is that the client curates the documents? Infinite. It is extremely important. It is extremely important because it's very easy to make the mistake of just shoving everything into the AI and let it work, and then nothing works. But so you need to do pre-processing a lot.
That's what I've been telling my people.
Yes. So yeah, last thing, just want to appreciate your time. Thank you for bearing with me and my horrible jokes. And
Exclude one, that was a good one.
no, yeah, yours was perfect. Yeah, I'm still in it, by the way. And yeah, please, if you have like crazy ideas, things you want to talk about, AI or not, or you want to discuss how LLMs now are the different life form species, if those are a thing, please come by and we can talk about anything. Thank you so much.